This is a flip video on moles and molar mass. Molar mass is just a name given to a conversion that we already know. So this is not going to be 100% new. Hopefully this should look familiar. Molar mass is the same thing as the mass that we get from the periodic table. So why do we call it molar mass? Well, mass meaning mass, molar because we know that all the masses from the periodic table are in 1 mole. So another way of saying it is, in other words, for example, 1 mole of carbon has 12.01 grams of carbon. That we know, right? Here's carbon from the periodic table. We look at its mass. So we call that a mass. We also call it an atomic mass unit. And now we also can call it molar mass. When we call it molar mass, we now understand that that's the mass in 1 mole sample of carbon. Okay? So let's take a look at some other elements just to verify. If you notice, this is nitrogen found on the periodic table. It has a mass of 14.01 grams. In other words, in 1 mole of nitrogen, there are 14.01 grams. Here's oxygen. It has 16.00 grams written on it in the periodic table. 16 grams of oxygen is equal to 1 mole. So it is a relationship between mass and moles. Nothing new. Okay? So if I was to ask you, what is the molar mass of carbon, you'd say 12.01 grams. It is found from the periodic table right there. All right? The only difference is now we are going to be doing the molar masses of some compounds. So let's take a look at maybe CO2, carbon dioxide. And if I was to say, let's get the molar mass of CO2. Basically, that's the mass in 1 mole. So 1 mole of CO2 is equal to, well, we're going to need to calculate the mass of CO2 in grams. So let's go ahead and do that now. So we've got 1 atom of carbon, 1 atom of carbon. We've got 2 atoms of oxygen, so that's O for oxygen, 2 atoms. Okay. And now we've got to get their masses from the periodic table, so we can add them all up to get a total mass. So if we find carbon on the periodic table, right, here's carbon, as you remember. So 1 atom of carbon, so we're going to multiply it by its mass. 2 atoms of oxygen, here's oxygen from the periodic table, times its mass. Okay? Now we want to multiply these and then add them up in the end. But let's remember, we need to make sure we're doing correct sig figs. Well, 1 is a counted number, 1 atom, right? I see 1 atom of carbon in CO2. So 2 is also a counted number, 2 atoms of oxygen. So I'm going to look here for sig figs. 1, 2, 3, 4 sig figs. 1, 2, 3, 4 sig figs. So 1 times 12.0, that's just 12.01 grams of carbon. Plus 2 times 16, well, 2 times 16 is 32, but I need 4 sig figs, so there you go, add some zeros. Okay, now I'm going to add these two together, and when I add them up, remember the sig fig rule goes, you want to go to the least places after the decimal. There's 2 places here, 2 places here, so my answer needs to have 2 places after the decimal. So these added up together should give me 44.01 grams of CO2, because that's carbon and oxygens being added together. This is my molar mass. So 1 mole of CO2 has 44.01 grams of CO2 in it. Or we could have also said this is the mass per 1 mole of that compound. That's a molar mass. Okay? Let's take a look at then a problem we would be given and how to solve for it. How many grams of carbon dioxide are in 5.50 moles of carbon dioxide? We're going to use the same dimensional analysis setup, and if you notice, I'm going to start with my given, and put it over here, 5.50 moles of carbon dioxide. Oh, we just talked about that. I'm going to multiply it by a conversion factor to convert it. Remember, whatever this unit is here, copy it down here, moles of CO2. Okay? How many grams are there? So I'm going to grams. Put grams of CO2. Do you know a conversion that goes from moles to grams? Hopefully you said you do, right? 1 mole of anything equals the mass from the periodic table. The mass in grams. Also now known as a molar mass. Same thing. Okay, going to use that here. 1 mole equals the mass from the periodic table. Well, I already got it. Here are all the masses I retrieved from the periodic table. Twice as many oxygens because we had CO2 and 1 atom of carbon. When I added them all up, I got the 44.01 grams. So you may want to make yourself a note here. You got this all from the periodic table. Okay, and if I was to say, show me this work, here's all the work. All right, good. Go ahead and plug this in your calculator. This would be 5.50 times 44.01. Top and bottom units cancel out. Your final answer should be in grams of CO2. Okay, let's look at another example. This is the final example. How about this problem? How many moles of NO are there in 2.00 grams of NO? NO is nitrogen monoxide. So we have nitrogen and oxygen. So let's go ahead and do the molar mass for this. We'll start here. We have 1 atom of nitrogen and we have 1 atom of oxygen. So 1 each. Here's nitrogen from the periodic table, 14.01. So 1 atom times 14.01 grams gives me just 14.01. Here's oxygen from the periodic table. Oxygen has a mass of 16.00. Again, this is NO, so there's 1 atom of oxygen times 16.00 grams. 1 times 16 is 16. Okay. Don't forget, when we add, we want to go to 2 decimal places. So notice I have 2 decimal places so far. It's 14 plus 16, so we just got to add these up together. So I got 30.01 grams of, let's keep in mind this was NO. This is NO's molar mass. I'm going to use it for my problem seen right here. Okay, so how many moles of NO are there in 2.00 grams of NO? Here's my given. I start the same way I normally do. Start with my given here, grams of NO. Now I want to multiply it by a conversion factor. I'm going from grams to moles. Whatever unit's here, copy down here, grams of NO. And I want to go to moles of NO. Is there a conversion that goes from grams to moles? Well, yes there is. Here it is. 1 mole, so 1 mole, equals the mass from the periodic table, also known as the molar mass. So here it was. NO has nitrogen and oxygen. I took their masses, added them up, and I got a total mass known as a molar mass. That's the mass in 1 mole. Molar mass in 1 mole. So now I just have to take my calculator and take 2 divided by 30.01. So take a second right now and do that. Your final answer should have 1, 2, 3 sig figs. 3 sig figs. That cancels out with that. And your answer's unit should say moles of NO. Again, pause the video and make sure you calculate that. Also remember, in our last example, to do correct sig figs as well. You always look at your given right here. 3 sig figs, so your answer needs to have 3 sig figs. That's the end of the video. See you tomorrow in class.